Hello friends, in this video I am going to discuss about the iterative search function in a binary search tree. We have discussed the binary search tree overview in one of our videos, and we have also discussed the recursive search operation in another video. So in this video I am going to show you how to perform an iterative search operation in a binary search tree. So iterative search function is quite similar to the search function. The logic of the very logic of the search function is similar to what we have done in the binary search recursive function. So in the recursive way we have done the search. Now we will find the key value. That is, now we are going to search the key value in an iterative way, that is with the help of the loop construct, not with the help of a recursive function. So suppose you know the search function's logic, and suppose I'm just going to draw a small binary search tree in order to show you just recapitulate what we have done in the previous video. That is, suppose this is a value 10, this is a value 5, this is a value 15. So this is a binary search tree. We are going to find a value, suppose 5, or suppose 15, or suppose 10. So if we are going to find the value 5, suppose the key value is 5. In this case, what we will do, we will start with the root node having the value 10. We will see whether it matches, and this 5 value match, whether the 5 value matches with this value 10. If they do not match, then we will compare whether this key value is less than the root node value or more than the root node value. If it is less, then we will definitely go to the left subtree starting from this root node 10, and we will try to find the 5 on the left subtree, and then we come to this root node. Then we start with this root node containing the value 5. This is the root node of the left subtree, and then we see that there is a match, and then the operation becomes successful. That is, the search operation becomes successful. We will return 1 for that, and if we do not find this 5 ultimately and fall off from the tree while we are searching, then we are going to return 0 to indicate that the search operation was a failure operation. So let me write the code and explain it to you what I have done, and let me see what I am going to do in the iterative search operation. So let me write the code first and then come back to you. So now let me explain the code which I have written on the board. That is the function written in an iterative way. That is, the search function is implemented in an iterative manner, that is with the help of the loop construct. So I have written this int search. That means this function name resembles the type of operation which we are performing in this algorithm, that is iterative search. So I have written like it search, which indicates it is an iterative search. Int is the return type. We have taken two arguments, that is bs node star root and int k. What is bs node star root? Let me again just recapitulate what we have done in a previous video. That is the structure definition of the structure definition of the binary search tree node. That is like this: type def struct bs node int data bs node star left star right. So this is the structure definition of the node of a binary search tree. So this root is a pointer to this type of data type, that is the user defined data type, that is the structure bs node. So this bs node star root is the pointer to the root location, that is the location or the address of the root node. This is the bs node star root, and int k is nothing but the search the value which is to be searched, that is the key value. So in that case in this case we have taken two arguments. We enter the function body and see what I have done here. I have written while root not equal to null double ampersand, that is logical AND k not equal to root data. What does that mean? These two are the conditions to be checked while entering the while loop. So since while is an entry control loop, we will first check these two conditions. If both of these conditions hold together, then only we can enter the while loop body or the while loop block, otherwise we will not be able to enter into the while construct. So this is one condition, that is root not equal to null. What does that mean? That is, the binary search tree should be in place. Suppose the binary search tree should be like this. Suppose this is the binary search tree, this is 5, this is 10 and this is 15. So this binary search tree exists. So if this binary search tree doesn't exist, in that case the root is going to be null. So if the binary search tree exists, we will try to enter this while block. Along with this, we have to check this condition as well, that is k not equal to root data. That is, k value should not be equal to the root data in the first instance. That is, if we find the root data in the first instance, we will be just returning 1, that is, we will find it in the very first instance. That is, a successful operation will be performed in the very first instance. So in that case, we will not perform this iterative operation. So in that case, so leaving aside that case where we will find it in the first instance, so that is the case where that is the condition which I have written over here, k not equal to root data. If the root data, that is this, we are going to search suppose 5 and this k value does not match with 10. So this is 10 and this is 5. So 10 and 5 do not match to each other. In this case, we will enter this while loop. So if both of these conditions hold at the same time, that's why I have written this logical AND operation over here, then we will enter this while block and see what I have written over here. If k less than root data, if k less than root data means if the k value is less than the root data, that is in this case, that is k value is 5 suppose and root data is 10. So we are definitely going to search on the left subtree with respect to this 10. And if it is more, then we are going to the right subtree part. So I have written like this, if k less than root data, then root is equal to root left. So root is equal to root left means that we are updating this root value. Root has a address value, root has an address value, like suppose I am importing some address over here, 655, 755, 855. Suppose this is an address of 655, this is an address of 755, this is at the location 855. So in this case, first the root will contain, in this case we will enter the algorithm with this 655 address and k value as 5. We enter these conditions, these two conditions hold. In that case, k is 5. And suppose this k is 5 and root data is what? Root data is now 655 arrow data, that is 655 arrow data is nothing but 10. So this is 10. So this is obviously the condition which is written over here, that is 5 is less than 10. So we will go on to this line, this expression statement, and update the root address to be the address of the root of the left subtree of this binary search tree. That is, the binary search tree starts from here, we go to the left subtree, the root of the left subtree starts from this 755 location, then we will update the root to be 755. Now the root will be what? The root will be 755. So root value is not 655 now, it is 755. Now in this case, see this, if 755 is there, then we come out of this while loop and again try to enter this while loop. See this, while root not equal to null. So root is definitely not equal to null because root is 755. And let me see this condition, k not equal to root data. Is this condition holding over here? This condition doesn't hold because see this, k value is 5 and root data is now also 5. So this is not a case of which holds this condition. That is, the first condition holds but the second condition doesn't hold. In that case, we will never enter the while loop for the second time. We will just go out of the while loop and see what I have written. Because of the paucity of space over here, I have written an arrow over here and just written the code over here. So please follow this line. If root equals null, return 0. So if root is null, so is root null over here in our case? No, root is definitely not null because this condition never holds. Root not this condition holds, that is root not equal to null. That is, root is not equal to null means root is 755. So in that case, we will not execute this expression statement. We will come to this else portion and see what I have written over here. Return 1. Return 1 indicates what? Return 1 indicates a successful operation. Return 0 indicates a failure operation. So we are going to return 1, which indicates that the operation was successful. Let me see whether it is successful. Yes, it is definitely successful because the root value of this left subtree is 5 and our key value was also 5. So both of them match and we find that we have done a successful search. So we have returned 1 in that case. So it is just matching with what we are putting the values in this algorithm, just like a dry run and performing a dry run and seeing whether this code executes in a perfect way. So the code executes in a perfect way. So this code is quite perfect, and it is and if you just call this code from a calling module like writing the main to it, and it can just be executed on the computer system. So this is the successful search operation. Suppose we are going to find a failure operation. Suppose, let me just put a value which is not in this binary search tree, and we are going to search that value so that it just returns 0. So suppose we are going to find, suppose 17. Suppose we are going to find a value 12. So suppose this k value is not 5, now 12. We start from here, 655, 12. These condition holds because root node is not equal to null and k not equal to root data because 12 is not equal to 10. So these two conditions hold. We enter the while loop. We see if k less than root data, k is now not 5, that is 12 now. 12 is not less than root data, it is greater than the root data. Then we come to this else portion, root is equal to root right. We set the root to be the address of the root right, that is root right is nothing but 855. So the root is now becoming 855. In this case, again we try to enter the while loop, root not equal to null, this condition holds, and see this k not equal to root data, k not equal to root data also holds. See this, k is what? K is 12 and root data is 15. So since k and root data both do not match, then this condition holds again. Then we again enter the while loop for the second time and see this, if k less than root data, k is 12 and root data is now what? 15. Yes, k is definitely less than the root data. Then we will go to this root is equal to root left. Then the root left will become what? Root left will now become null because this left pointer points to null and right pointer also points to null. So if we go to the left of this, we find that the root left is null. So this root now will become null, and we go out of the while loop and try to enter the while loop once again. Root becomes null. So we need not check this condition because root becomes null, because the first condition doesn't hold, that is root not equal to null doesn't hold. That means root equal to null. We will not go to check this second operation because there is no need for that. So we will go out of this while loop and go to this portion. See this, if root equals null, then we are going to return 0. So our root is null, so we are going to definitely return 0, and that indicates that the operation is unsuccessful. See this, 12 is never to be found in this binary search tree. This binary search tree contains three values, that is 10, 5 and 15, and never we will go on to find the value 12. So this is an unsuccessful operation. So that's the end of the explanation of the entire section. So if you have any doubts or queries pertaining to this program or this function, you can well post your doubts and queries into the comment section below so that I can address them. Thanks for watching this video.